Hello brother and sister. In today's video, we are going to discuss about Lagrangian and its important questions. So if you want to just look the important question which have come in the previous CSIR net, then you can skip the 5-minute video and you can watch. So before discussing those questions, I am telling you about the Lagrangian formula and its Lagrange equation of motion. So what is Lagrangian? See, as I have told you before also that we don't need to go in a detail of everything. Whatever is important, whatever is required, we are going to discuss that only. Whatever is important from exam point of view. See, what is Lagrangian? It is T minus V. What is T over here? T means kinetic energy and V means potential energy. So Lagrangian is simply kinetic energy minus potential energy. So this is the Lagrangian. Now what is Lagrangian equation of motion? See, let's define QK. This is the position of a particle. Now if we want to write the motion of a particle in a Newton's law, then that we can also write in the form of Lagrangian, and that is given by Lagrangian equation, and that equation is simply d by dt del L by del QK dot. What is QK dot here? QK dot is velocity over here. QK is position of the particle, and if we are going to differentiate it, QK, if we are going to differentiate it with time, then it will become QK dot. Means dQK by dt will give you QK dot minus del L by del QK. It's del over here, okay, and it is also del, and this is d by dt is equal to 0. This is Lagrange equation of motion. Okay, now let's study generalized momentum. See, if L is Lagrangian of a system which is T minus V, as I have just told you, L is a Lagrangian of a system which is T minus V, and d by dt del L by del Q dot minus del L by del Q is equal to 0 is Lagrange equation of motion, which is equivalent to Newton's law of motion. So it is equivalent to what? Newton's law of motion. If Qi dot is generalized coordinate, if Qi is a generalized coordinate and Qi dot is generalized velocity corresponding to Qi, then generalized momentum conjugate to Qi is given by, they are saying that suppose if qi is generalized coordinate is qi and qi dot is its velocity, then the generalized momentum pi conjugate to qi is given by, see, the momentum given in the form of Lagrangian pi is equal to del L by del qi dot. So the generalized momentum conjugate to qi given in the form of Lagrangian is del L by del qi dot, which is pi. Generalized momentum can be linear momentum or angular momentum, depend on what is dimension of generalized coordinate. See, generalized momentum can be linear momentum, angular momentum, it can be anything. It will depend on the dimension of generalized coordinate. What is the dimension of generalized coordinate? Next comes cyclic coordinate or conservation of momentum. If Lagrangian is not explicit function of any generalized coordinate qk, then qk is cyclic coordinate. It is saying not explicit function. Not explicit function means implicit function, okay, of a Lagrangian. If anything which is implicit function, then that is given by del L by del qk is given by 0. As I have told you yesterday also, that implicit and explicit type of function, if something is implicit type, then differentiation of that function with respect to time will give you 0. That is implicit type of the function. So here what they are saying, cyclic coordinate or conservation of momentum. If Lagrangian is not explicit function of any particular generalized coordinate. If Lagrangian is not implicit function of any coordinate, that means del L by del qk is equal to 0. Means Lagrangian is an implicit function of generalized coordinate. So we can write it del L by del qk is equal to 0. Okay. Then qk is a cyclic coordinate. Then we can call that coordinate as a cyclic. Now this coordinate is known as cyclic coordinate. So what we have learned up to till now? Till now we have learned that Lagrangian is kinetic energy minus potential energy, and if qk is a position of a particle, qk dot is its velocity, we can write the Lagrangian form of equation in the manner d by dt bracket del L by del qk dot minus del L by del qk equal to 0. And we can write generalized momentum which is conjugate to its velocity in the form of Lagrangian, that is del L by del qk dot. And if Lagrangian is an implicit function of a coordinate, then this qk is a cyclic coordinate. If qk is cyclic coordinate, then non-conjugate to qk is pk is a conserved during the motion. If there is a cyclic coordinate, if this is a cyclic coordinate, qk is a cyclic coordinate, then corresponding to its momentum pk will be conserved in an equation of motion. pk is conserved in equation of motion. qk is a cyclic coordinate, then corresponding to its momentum, conjugate momentum is conserved in the equation of motion, because that is d by dt del L by del qk dot equal to 0. If something is equal to 0, that means del L by del qk dot equal to constant. Look here again. See, what is the Lagrangian equation of motion? Lagrangian equation of motion is d by dt del L by del qk dot minus del L by del qk equal to 0. As I have just told you, if qk is cyclic coordinate, it is an implic type of a function, then del L by del qk is equal to 0. So what are we left with? D by dt del L by del qk dot equal to 0. And something, differentiation of something can only be 0 if there is something constant. So del L by del qk dot is equal to constant, because d by dt, if a is constant only then differentiation can be 0. Okay, so what is a constant? Here del L by del qk dot, what is over here? Constant. Okay, so that's why corresponding to it pk is, which is its conjugate momentum, is conserved during equation of motion. Okay, now let's start the questions. Okay, question is given, a system for 3 degree of freedom. System of 3 degree of freedom. Look here, what is given in the question? 3 degree of freedom is given by a Lagrangian. Lagrangian is given to us. What we need to find out? We need to find out, identify generalized coordinates. What are its generalized coordinates? What is its generalized velocity? Find generalized momentum and write Lagrangian equation of motion. Okay, pause. See what is given to us in a question. In a above question, what is given to us? Lagrangian. L is equal to half m x dot plus y dot square plus z dot square minus half k x square plus y square. Identify generalized coordinate. So from this, what we need to find out? Generalized coordinate. So what are the generalized coordinate? See, degree of freedom is given to us 3, and generalized coordinate can be easily seen by us. That is, generalized coordinate are x, y, z, which is equal to the 3 degree of the freedom. Okay, next what they are saying, what are the generalized velocity? Generalized velocity are, generalized velocity x dot, y dot and z dot. Now they are saying find the generalized momentum. What we need to find out? Generalized momentum. So generalized momentum are given by px. For example, we need to find out px, that is del L by del x, py del L by del y, pz del L by del z. So what is px? Del L by del x. This is the Lagrangian, and in this Lagrangian we need to find out what? Px, okay, that is equal to del L by del x dot, y dot and z dot. So what is del L by del x dot? See, if we are going to differentiate over this, it will become 2mx dot by 2, which will give us px is equal to mx dot. Py will give us my dot and pz will give mz dot. Now what we need to find? Lagrangian equation of motion. We will find out this Lagrangian equation of motion. But before that, we also need to find out cyclic coordinate. See, many times in a question it is asked, find out the cyclic coordinate. The simple way of finding cyclic coordinate is that if we are given generalized coordinate in Lagrangian, if we are given generalized velocity in an equation but conjugate to its velocity is not given. For example, z dot velocity is given but its generalized coordinate is not given in the equation, means z is not given in this equation. So this z is what? This is known as cyclic coordinate. So what is z over here? Cyclic coordinate. So del L by del z is equal to 0 and corresponding or conjugate to it pz. This pz is conserved during equation of motion. Now what we need to find out? Lagrangian of the equation. For Lagrangian of the equation, what we will do? We will write the formula of it and we need to find out. D by dt del L by del Q dot minus del L by del Q. See, from here only we can find out del L by del Q dot d by dt del L by del Q. here what is there? X is there. So del L by del Q dot means del L by del X is what? Mx dot. Okay. And if we are going to differentiate it with d by dt, it will give mx double dot minus del L by del Q. It will give kx. Next will be my minus ky. So these are equation of Lagrange equation of motion. Simply put the value of L in the equation and differentiate accordingly. You are going to get Lagrange equation of motion. Okay. Next question come. Transform the Lagrangian into cylindrical coordinate system. Then identify generalized coordinate, velocity, cyclic coordinate, conservation of momentum and equation of motion. Okay. Let's see what is given to us. We need to transform the Lagrangian into cylindrical coordinate. First of all, we need to convert the Lagrangian into cylindrical coordinate and then identify generalized coordinate, and after that we will find out the generalized coordinate, then velocity, then momentum, then conservation of momentum, then equation of motion. Say this is the second question, and such type of the questions are, various questions are there, and those are given up to 7-8 questions are there. And after Lagrangian, Hamiltonian is started. So this other example I'll tell you in next video. So please share, subscribe as much as possible, because then I'll also get motivation to make videos. So again I'm saying, please share and subscribe it. Thank you.